Okay, good afternoon, everyone, and welcome to the CEPREC webinar series. It is with great pleasure we have Professor Muyiwa Owinola, who is also the PI for the CEPREC project and will be presenting today's webinar entitled From Knowledge to Implementation, Building Capacity for Circular Renewable Energy Systems in Africa. Over to you, Muyiwa.
Thank you very much, Nitika. Good afternoon, everyone. I hope you can hear me okay. So today we'll be looking at a webinar focused on Work Package 8 of the CEPREC project, and it's titled From Knowledge to Implementation, as Nitika has said. And it's all about how do we build capacity for the whole circular energy. So throughout the whole webinar, I'll be taking you through some of the things that we were doing and what we've learned. So if we think about the whole concepts of energy, so you think about a school in Africa, or let's say Ghana, somewhere in a rural village, who have installed solar panels and inverter and battery storage. We know that that's progress from what we know. However, what we understand from what we've been seeing across the continent is that the story doesn't end there. Sometimes things happen to the systems and they remain unusable for a long time. Okay, so the question is, what happens when things begin to degrade and co? So the normal thing that we're used to so far, because we've been trying to accelerate the whole idea of energy access, is we design, we deploy, we operate, and we maintain. Okay. Most of the times we have our panels degrading, our batteries lose capacity, inverters fail. Now that we have the whole idea of electric mobility, we have electric vehicles on the roads, and the stuff, they reach the end of their lives in a few years, and we'll have quite a lot on our hand. So the question now is, how do we think about the whole life cycle of these systems? And that's the whole idea of the whole circular energy systems, where circularity is embedded and optimized for different renewable energy assets. So if I go to my next slide, as I said here, this is the usual model where we import, install, use. When it fails, we discard, and then we throw that out of the system. So value leaves the system. However, what we are saying is that the opportunity is we go beyond that, and we are maintaining our systems for as long, making sure we can repair them, reuse them in different purposes, um, reuse them, and then repurpose them as well as recover them. So what we're saying is, in this circular system, value stays, and not just in use, but it stays local. Okay. And what we've been proposing from our project is that we circular energy must be clean energy must be circular, inclusive, and built to last. And that's the whole idea of circular energy systems. So if we go to the next slide, what you see here is that it's not, when we talk about circularity, it's not just a waste topic, and you see that in a few slides where I will show you what it's all about. But it affects different parts of the implementation ecosystem. Okay, so when we talk about circularity, it will affect how long assets can last. It also touches on policies and standards, which I'll be presenting to you. It requires investment confidence. We need to build long-term trust. It also has impact on critical materials and the likes. So there's quite a lot of things out there that we need to consider in terms alongside circularity. Basically, how do we make circularity work, and what are the things that circularity can help us to achieve? Okay, so at this point, what I'll do, as I know that it's a public-facing webinar, I will set some time just to quickly tell you about us and what we do and how how we're trying to achieve the whole idea of circular energy systems. So, when you hear what you would have seen is we're called CEPREC, and that stands for the Circular Economy Powered Renewable Energy Center. And we are Pan-African, multi-sectoral, and interdisciplinary. And as our name suggests, we are leveraging the principles of circular economy to advance Africa's energy transition. We are funded by the UK government's 18 fund, which is a 1 billion initiative supporting clean energy research and innovation. Fundamentally, we're here to understand how Africa can expand clean energy access without creating the next generation of waste dependency and unsustainable infrastructure. So, yes, we are accelerating to have energy access, but how do we ensure that that transition doesn't create problem for us in the future? And we have a three-pronged approach, which is firstly to create new knowledge, to build capacity, and thirdly, to influence policy development. This is what the consortium looks like across the continent. So three organizations in the UK and 8 universities spread across East, West, and Southern Africa. This is what our work looks on. So we have the technical side of things, for work packages, we have the social science side of things, but underpinning this are two things. One is the impacts, policy influence, and government engagement, which we've been in quite a lot of. And the other one is why we're here today, which is the whole idea of capacity building and and dissemination. So this webinar is part of that, as well as what I'll be talking about is the whole idea of capacity building. So again, just to show you the spread across the continents for those organizations, I've said we have two countries in Southern Africa, South Africa, and Namibia. In East Africa, Kenya and Rwanda, and of course West Africa, Nigeria, and Sierra Leone. So across sub-Saharan Africa, um, have over 30 partners across industry, government, and academia. And this is what we've been doing in terms of our work package 9, trying to ensure that we're influencing policy across board. So we're just not doing research, but ensuring that that research gets to the people that need it to make decisions for countries and the world at large. So that's what it's all about. But if I go back to what we're here today, we're talking about the whole concept of circular energy. All right. And when we think about it, most of the time, when you talk about energy access or inside energy, we think about technology deployment. Okay. And that is fine in itself. However, what we are saying or the argument we have been making at CEPREC is we need to think about it in a longer term. So in terms of the whole idea of circular implementation. So when you have a technology, we need to think about who can maintain it, who can repair it, who can finance it, who can regulate it, who can repurpose it, who can recover value. So it's just thinking about all those things that will affect the life cycle and ensure that value is retained for as long as possible and that we are able to ensure that the environmental footprint is minimized. Okay. Um, so when we talk about technology deployment, it's not just about technology is easy to move to any part of the world, but when you now think about the capabilities that we need to ensure that we have a truly circular implementation, that's where the story becomes much more interesting. And what we're saying is that without those capabilities, we can't really expect the whole idea of circular energy to scale. So throughout this webinar, I will be discussing some of those things that we have observed from the field and from our research that we can go forward. But For us as a project, one of the things, the frameworks that we've adopted is the 9R framework. So there are quite a lot of frameworks available out there, but this is just one that we've been using in our capacity building programs, and we've adapted that for energy systems. And what you can see here is that there are 10 um, actions that we can take that all start with R. And the first is refuse, and the lowest is recover. And they all have different roles to play. And we can't always apply the same thing every time, and it depends on what we are facing. And that's what we've been obviously discussing and engaging with people and stakeholders from um, all across government, industry, academia to ensure that we can think about this and how it applies. And so we can move this from simple theory to actual implementation. Okay. So again, I'm sure, I don't know if people here agree with me, but generally, when people hear about the whole concept of circular economy, the first thing that comes to mind is recycling. However, what you'll see um, here is that recycling is actually the penultimate in the chart to the bottom. Okay, so recover is just the only one after recycle. And when we talk about circular economy, we want to be higher up in this chart. Okay, so what we're saying is we need this framework helps us to think earlier and more strategically. Okay, and that's what we're doing as CEPREC is how do we now start embedding the whole principle of circularity into the whole energy system? So even as we're designing, how are we designing for circularity? When we're passing policies for energy, how are we passing policies that support circularity? And when we're talking about components, how are they built? Are they built to be reused, repaired, or refurbished, or are they just sealed? Okay. Can we downgrade stuff? So like one of the big things we are doing is looking at electric vehicles and seeing how we can repurpose those components for lower demand or lower demand scenarios. So obviously, the demand in mobility is much more aggressive than that in stationary. So when at the end of life of those components, can we transfer them? So it's that whole life cycle thinking, that whole systems thinking approach that we're saying that we can. Okay, so again, here we have grouped this into three levels, and the first is talks about avoiding and optimizing. Okay, so how do we refuse, rethink, and reduce things? Okay, just so that we avoid the use of materials and the likes. Secondly, how do we retain product value for long? So that's the whole idea of reusing, repairing, remanufacturing, repurposing, and all that. And then lastly, where we should only use as last resort is the whole idea of recycle and then recovering materials. Okay. Um, and then I've put something there below where what says recycling matters, but it should not be the first circular option we reach for. Obviously, the first circular option should be can we refuse? Do we really need that? Um, so that's the 9R framework at a glance. Um, and so when we talk about that, we need to think about the capability for those for the whole all the actions in the 9R framework. Okay. So it's not just the principle when we talk about circularity, all of those options require people, require systems, they require institutions. Okay. So, for example, we talk about repair. How do we have technicians to make sure they can repair different components? Do we have spare parts? Do we have the right equipment and tools? Okay, when you talk about repurposing, we need the safety protocols and testing. We need all that. Okay, And then, so all of these things, as you can see here, need capabilities. Okay. And what this slide is telling us is circularity becomes practical when actions are matched with people, tools, and institutions. So, for us as a project or as a center, what we're saying is how do we map all these things? What is needed across Africa? What are the gaps, and how do we close those gaps? Okay, so we think about the circular economy principles, and what are the capabilities, and then what is the trusted implementation pathway. So and then we can think about look at the whole idea of circular energy systems as life cycle systems. Okay, so we can't just look at a mini grid or a microgrid as something that is just for generation storage and then supplying a load. All right. So they require life cycle planning, as I've said before. How do we source the components? How are they operated? How are they repaired? How are they maintained over time? Okay. So, what we've been looking at over the whole project is specifically looking at electric vehicles from the engineering side. How do we repurpose and how do we apply these principles to that? But again, you can take that into a bigger sphere of things. So if we take, for example, the case of batteries, all right, and I've titled this Promise and Caution, okay, because even though we're looking at it as a second life application, and yes, it's good for the environment or whatever we've talked about, we need to think about it from a safety perspective as well. Okay, so yes, if you take a second life battery you have from a car, you can use it for stationary storage. You can use it supports mini grids, even help with productive use in rural areas, which is not just supplying energy but also improving the economic conditions of populations, and we're maintaining value. However, for that to be a reality, we need a few things to be in place. Okay, so quite a few things. We need to be able to understand the state of health of that component. So in this case, a battery. And how do we do that? We need to ensure that the battery management system capabilities is in there. We need safety protocols for, firstly, not just dissecting or um, dismantling these systems, but also for their operation in their second life and co. And I think quite importantly is the idea of standards and responsibility. Okay, so whose responsibility is it? So if you buy a second life battery, does that all of a sudden become a responsibility? What happens if 2 weeks after it's packed up, or God forbid you have a an accident? So those sort of things are the type of considerations we have to put in place for circular energy systems to be a reality. Okay. Um, so yeah, basically what we're saying is safety, performance, and responsibility has to be or have to be credible for people to do that. So I've just given you an example of a battery, and if I but what we're doing at CEPREC goes beyond just batteries. So for batteries, my colleagues in Work Package 2, which we've done a webinar on a few months ago, which you can catch up on YouTube, are looking at those batteries. But Professor Latishe from University of Warwick is looking at Work Package 1 and doing quite a lot on the whole power electronic side of things, inverters, converters, and the likes. And Dr. Bola Kuru in South Africa is looking at motors. Okay, and what you can see on this slide is just how we can take different parts of that electric vehicle at the end of life and use it in stationary energy applications. So electric vehicles are part of the energy transition. They have a finite lifespan, And at the end of that lifespan, can we still extend the life of some of the components and use for to support energy? Our research and general consensus is yes. And so what we're doing is how do we ensure we can make that happen? How can that be a reality? So that's that. And the next slide talks more about keeping value in use and value local. Okay, so we're looking at the whole idea of, okay, you have a user, and if the whole circularity is how do you keep it local? Okay, so you need those technicians locally, you need those that local enterprise and all that. So it's we need the infrastructure locally to be able to support the whole circularity transition. Um, and so what I'll be talking over the next few slides is more about the capacity gap. Okay, and I've based on some of the data we've been getting or the conversations we've been having over time, we can group this into five um, groups. Okay, so the first one is technical. I'll go through all this shortly. Second is more stakeholder institutional. Third, business and finance. We have governance and standards, and data and digital. Okay, so what we're saying is that for when we talk about capacity building, we need to connect people, tools, rules, finance, and coordination. Okay, so the whole idea of capacity has several layers. Okay, and that's what we'll be looking at. So, for example, technical, we're saying, can people really trust? Can people test, repair, and maintain the system? And that's a very key question we need to answer. So, what we will talk about first is the idea of technical capacity. Okay. And I'm sure you agree with me that this is the most visible form of capacity building. Okay. So, over time, you've seen quite a lot of renewable energy systems in remote areas that have backed up just because um, poor installation, poor maintenance, or low quality components, okay, or weak after sales support, okay. So if you think about that in actual systems that are new off the shelf, those are bringing problems. You can imagine what we need to think about when we're talking about second life, reused or refurbished components. Okay, so we need much more credible testing and monitoring. And so that's one of the things that we think about in terms of technical capacity. How do we ensure that that installation and maintenance of Second Life is top notch? How do you ensure that there is real time testing and diagnosis of systems? How do you ensure that there's access, you can repair stuff locally and assess components viability or lifespan? Okay. And I think quite importantly, or most importantly, if I may say, is that assurance of quality. Because nobody will want to take a system that they're not sure of. Okay. So regardless of that, okay. So what we're doing is, as I showed you at the beginning, we have that those four work technical work packages. Okay, first is looking at power electronics. Second is looking at batteries. We have the third looking at thermal systems, and then the fourth one looking at the whole system modeling and how all these things come together. And so what we're doing is we're converting all those learning, those research outputs into capacity building tools and workshops so that people can understand and actually use those sort of things. The next one is more on the data side of things, okay? And based on what I've explained is more, you can see that this is quite used needed because of the nature of that, all right? So you need you need quite a lot of oversight, all right? And when we talk about the whole idea of digitalization, it's not just for adding technology on its own, but it's about being able to improve decision making. Okay. Um, so I've put some concepts here about what data is there to know. So for example, who is responsible, how systems perform, when batteries degrade, and all those sort of things. And you need all that idea of predictive maintenance, digital twins, and the like. So the whole idea of data and digital capacity is a very, very big part of the whole circularity transition. And we need those capabilities. So not just people that can do that, but the systems, technologies, tools to be able to do that. The good thing is that across the African continent, there's that leap in technology. We also have AI that has transformed the world. So that is getting more and more available. But I think we need to make sure that it is deliberate and it is managed and it is built into systems to ensure that we can make the best of those the data and the whole digital transformation. The third one is the idea of governance and standards capacity. Okay, so when we talk about circularity, it requires trust. Okay, people need to be able to trust that, for example, the second life battery is safe, and that if you refurbish an inverter, for example, it will perform as claimed. And if you want to dispose of your system to a recycler, you want to be sure that they are doing their responsibility responsibly, and everybody's meeting their own obligations. So you need that oversight, which is usually from government or government agencies, to be able to firstly put those standards in place, to be able to govern, to make sure they're enforcing. And it's not just policies, but policies are enforced and all that. So when we talk about that whole capacity, we're thinking about how do we build capacity of these regulators, of these government bodies to ensure that firstly, the policies and the standards are fit for purpose. Secondly, they understand what's going on. And thirdly, that they are enforced. So it's the whole idea of that in the system. Um, and then the other fourth one is the business and finance capacity. Okay. So we think about the whole life cycle cost and co, and we can have a technically sound circular energy solution. Okay. However, if we don't have the right business model or we have a weak business model, it will fail. Okay. So what we're saying is basically how can we ensure that affordability is protected. Okay, and there are quite a few models. My colleagues in work package 7 have been doing quite a lot on this. I think we've had 2 webinars on that, and we'll still be having some in the future, but there are different models that are out there to ensure that we can make circular energy systems something that people can use and afford. Okay, so just some things there: energy as a service, battery as a service, and the examples from across the continent. So I think Basico in Kenya is one good example. Okay, but again, when you look around, you see some questions that need real answers, and yeah, that's what I'm thinking about. So who pays upfront? Who owns the assets? Who maintains it? Who replaces components? Who recovers value? Who carries the risk? And so all these are things that need to be considered um, very, very carefully in that whole circularity space. Um, Again, we've had the webinar on that whole collaboration and the whole business model, which Dr. Abiokoya did a few months ago. and is one of the things we have been trying to say or do is to ensure that it's not there's no silver bullet, there's no single actor um, that can do everything. It's an ecosystem challenge, the whole idea of circular energy systems. And while governments can set standards and policies, and industry can develop products, services, and all the um, schemes they have, as universities, we can keep on generating evidence and train people. Communities will always give us the lived experiences and feedback. Okay. And most importantly, well, maybe not most importantly, but finance actors can shape what can scale. All right. So everybody has a part to play. And as I said, we've done a webinar before where we've talked about the approach we're doing, looking at the triple helix, bringing academia, industry, and government, but also engaging with people and as well as civil society and engaging with the users. So that whole idea of circularity is quite important. Okay. Um, in in terms of where we should go next, okay, so what I've done is just a few things that um well, more or less take homes for different audiences. So firstly, looking at funders, usually they support pilots, but when you talk about scaling, it mainly depends on the surrounding capabilities, the skills, the finance, and all that. Okay. So one of the things that we've been looking at during our work is that a stronger funding agenda should support implementation readiness alongside technology. Okay. So basically, how do you ensure that um, skills and technician training is in place? There's testing and certification, collaboration, the policy and standards and co. So it's looking at it at that from that side of things to ensure that the implementation readiness is there and not just funding pilots, because you have quite a lot of pilots across the continent but haven't scaled. So one of the recommendations that we'll be giving is that whole looking at that readiness and ecosystem approach. In terms of government, we have done a few things, and my colleague from Chatham House has given some presentations and webinars in in the past. But what you can see here is just some recommendations, and mostly what we're saying is we need to connect those energy, waste, industrial skills, and finance policy together. We can't go very far if we keep treating them in isolation. Okay. So yeah, for example, looking at industrial policy, how do we ensure our industrial policy supports repair, refurbishment, and local value chains? Um, how do we integrate lifecycle value into energy policy and the likes? Um, and so for universities, which is where CEPREC sits predominantly, these are just some of the things like ensuring that that second energy curricula is there. We can disseminate state-of-the-art knowledge with technicians and engineers. We can build student and early career pathways. We can work with industry on real problems. Okay, and so looking at it in three different approaches is firstly the whole idea of applied research, which is what we're doing, convening stakeholders, government, industry, and academia, civil society. And we've been doing this, we've done it at COP, at the subsidiary bodies, UN Climate Change Convention. We've done it in at UN headquarters. So we keep bringing people together just to ensure that that stays on the table and people can understand what's going on, what the evidence is, and what the direction should be. Okay, so it'll be good to see more of this in that circular energy space. And then again, industry has a big role to play in terms of looking at their whole responsibility across the life cycle, how they design for repair and the services they offer. Okay, so what I've done on this slide is just summarize the argument, and it's not essentially that we're saying we're against technology. We have quite a lot of technology out there, but it's more how do we implement and scale. So what we're saying is we need systems that retain value throughout. So when we're talking about deployment, we need to be thinking about the whole life cycle value and not just deploying a lot of pilots and the likes. We also need to think beyond recycling, of just thinking about recycling, but looking at the whole full 9R hierarchy. So starting from refuse and all that. Okay. So rather than just doing technology pilots, which we have quite a lot of now, we need to look more at the whole systems perspective in terms of capability and all that. And similarly, when we talk about isolated projects, indeed, from what you've seen, we need that whole ecosystem, looking at the whole circular ecosystem and looking at not just the project, but also there's the whole repair side of things, there's repurpose, there's the end of life, value recovery, all that. Okay. And then we need to look at quite a lot about the idea of implementation pathways. Okay. So to end, this is just the closing slide, and it's more about summarizing everything. Okay. So which is the central argument, which goes back to our central argument as a project. And what I try to say is Africa's energy transition must be fast, but it must also be durable. We must be able to retain value for as long as possible. So for circular energy to scale, that circular capability needs to scale. So we need circular energy to be circular by design, inclusive in practice, trusted by communities, finance for life cycle value. We need policy to enable it, and we need the skills that will support it. And most importantly, it must be built to last. Thank you. So I will pause now for questions. If you have a question, I think if you raise your hand, we can unmute you. Do you have any questions? Okay. I can see.
Amin, there's a question.
Yeah. So yeah, I think Amin and Bola both have questions, so you can unmute yourself and ask your question.
Okay, I can go first if it's fine. If it's fine. Thanks for your presentation, Prof. Yeah, so the discussion around the circular design is critical, like you have highlighted, based on the CEPREC projects. So my question is, and I think maybe for people who we interact with, stakeholders, is it is one thing to design the system. It is another thing to use the system. So is there a way that this concept can be integrated to the usage of the system? when it has been designed. So is there anything like circular use? That is one. The other question is how do we differentiate between um, circular economy and sustainability approaches? So is there any difference? I know you're a professor of sustainability engineering. Okay, thanks, bro. Those are my questions.
Okay, thank you very much, Bola. So your first question about secular use. So I guess if you think about it, right, the whole idea of circular economy, well, it depends on what of the hours you're looking at. But as I said, there's the there's the 9R framework, all right, and most of these have outputs. Okay, so if you think about the whole idea of refuse, all right, we're telling people to avoid unnecessary or sustainable technologies. So that's why we're saying that you don't need to use things that are unnecessary. Okay, so when we think about rethink or reduce, we are all saying reduce material use, energy. So I think inherently all these 9Rs are about how do we ensure people use less. Okay, so I think the whole idea of circularity has to do with that. So it's not, yeah, it's about that whole systems perspective. So I think what I'm trying to bring out is like, for example, if you reuse something or repair something, ultimately is for someone to use. Okay, so that whole stuff. I don't know. Does that answer your first question?
Yes, that's spot on.
Okay. So the second one is about sustainability and circular economy. All right. So in simple terms, I'll say sustainability is the broader goal. So it's as you will have probably guessed or come across, it's there's the environmental pillar, there's the economic pillar, there's the social well-being pillar. Okay, so they're usually referred to as the three pillars of sustainability. Okay, so that's the whole idea of so how do we ensure that we balance environmental protection, economic prosperity, and social well-being. But when we talk about circular economy, it's just one approach to achieving sustainability. Okay, so that whole idea of circular economy is focused on keeping products, components, and materials in use for as long as possible. So you can say circular economy comes under sustainability because sustainability is much wider.
Oh, I see. Thanks for the clarification.
You're welcome. Yeah, welcome. I mean,
Hi, hello everyone. Good afternoon. Can you hear me well?
yes, clearly.
Amazing. Thank you very much. Thank you for the very great presentation. I'm in Fakhr. I am a master student in engineering and policy analysis from TU Delft from Netherlands. I really liked your presentation because my research topic is aligns quite well with the reliable grid scale storages for electricity, which is nowadays also like a problem or like a topic that Kenyan government and Ministry of Energy is now trying to in Kenya trying to like expand and like invest on it. So my specific question that how do you see about grid scale storage in terms of the technologies is nowadays available and which options are quite good enough to bring a valid energy how do you say performance for the Kenyan government and which actors are now are active on this ground.
Okay, thank you, Amin. I guess your question is more about storage for grid stuff, and well, that's really not my area. I don't know if we have any of our storage people on the call, but I know there are different types of storage available, and technology keeps on getting better and better. I'm not sure about the whole Kenya particular situation, but yeah. Do we have anybody from Work Package 2 on the call that can speak to that? So the whole webinar was about circular economy and the likes. And for this project, what we're looking at is storage for batteries. That doesn't always work well for grid storage. Maybe for more smaller scale storage, we can do that. But I know there's lots of talk on compressed air, all that. So yeah, I will pass on to Professor Sarah.
Sarath is on the
Sinakun.
call.
Yeah. So I just need. Yep. So
Yeah, I
Professor
appreciate
Sarah,
if you can, yes, of course, indeed, refer me to the right person that because
Professor,
that
can
would be
you?
my, yeah.
Okay.
Yeah.
Yeah, Professor.
Yeah, I'm unmuted now, so
Yeah.
I can speak. Can you all hear me?
Yes, we can.
Okay. I did not really get the complete fully, but I think it is about the storage in the sort of circular or second life batteries type thing. So what I can say is that the batteries from an electric vehicles, when the end of life reaches, we can take them out and dismantle it. And although the whole battery is perhaps down to about 80% of state of health, and it is still useful for other applications, but some of the cells might not be so good. So all the cells get tested, and we get the good cells and repurpose it for a different application. And one of our students established a company, Second Life Storage, and they are in business, and that is what the business is about. We produce Second Life batteries, and we sell them to various applications. And the latest thing is we have supplied it to a mini grid in Zambia. I don't know whether that answers the question.
Yeah, I appreciate that very much. I may have like a quite bit further questions from you, Professor Saraf. If you mind, if I can have your contact information, I may ask a few more specific about what are the challenges about expanding this technology, and would that be a key focus for the government, maybe in Kenya, to expand or this or invest on this?
So again,
Can
I think Karen, sorry.
Okay. I'm just going to say, whether is it possible for me to put my email address on chat, or someone else can give it to the person?
Okay,
Let's see.
that's fine. Yeah,
I think I can write anything on chat, I think.
Yeah, that would be amazing. Thank you very much. And thanks,
Yeah.
Professor Lola. Yes, yes.
Lola, thank you. Yeah.
Yeah.
Yeah. So
Yeah.
what I was also going to say is that when we talk about storage, there's the more there. Well, it can be either short term for more or less frequency regulation, voltage support, and the likes, or the much longer term ones. So I think, yeah, you need to look at those sort of things. But there's quite a lot of things out there. So pumped hydropower, thermal storage, flow batteries, all the sort of things are things that you can consider for grid storage. But for us, we've not been looking at the whole, it's more on the mini grid, microgrid scale. And we are looking at lithium-ion batteries, a bit of thermal storage. Okay, any
Thank
other
you very much.
question? Any other question? Okay,
I had a very quick question, Moira. What do you think are the key challenges of capacity building in the Global South?
That's a good question. So I think the key challenges of capacity building in the Global South will be firstly the scale and getting to the right people. I think so, yeah, making sure the right people have the right training, and then also if it's more specialist training, I think the equipment, the and the whole environment for that capacity building side of things. And it's one thing to build capacity, it's another thing for them to be able to use that capacity immediately. So if you don't use the skill, then it fades out. So I think also, so like for example, most of the workshops we've done and all the materials we've been able to do, if they don't have ready projects they can use those things on, I think it will be a bit difficult for them to keep those skills or those things they've done. Yeah, and I think finally what I'll say is that it needs to be a continuous thing, not a one-off thing. And so having that the resource to do that is important. So for example, we've had workshops in 3 countries, Nigeria, Sierra Leone, and Kenya. And most of the feedback is, oh, the workshop was too short. They want more workshops. They want longer. So you have all those coming out on the feedback. So yeah, I think that's what I would say off the top of my head. But yeah, I'm sure there are more. Okay, so I see Ore Olufamiwa has a question.
Hi, Prof. Good afternoon, Prof.
Afternoon.
Yeah, sorry, there was something you were saying about like getting stuff that's like marketable and not just like proof of concept and stuff. But if like from our research side, it's quite difficult before you get to that stage. So what's like a usual time frame that funders look at and like other people, stakeholders?
Okay, thank you for that. Right. I'm not sure there's a single answer for that. I totally agree that there's a process. All right. So you first start off in the lab, you come up with your proof of concept and code. But I think what I was referring to in the slide was more about looking at the whole system. So like when you think about funders, people are happy to fund pilots and that's it, and then people are left to go on their own. So that this is more for higher TRL stuff. Okay. So when your technology is proven and is ready to go to the market and the likes, you need to be able to go you need to be able to scale. All right. And I think that's where the whole idea of the environment around, and I was talking about capability. So it's not just you have a good idea, you've proven the technology and it will scale. You understand? So it's like what do we what do we need to do? So if you're familiar with the TRL whole framework, right? Technology
Yes, I
readiness
am.
level.
Yes.
Yes. So once you are in that um 8 or 9 level, then you can you can be looking at that. But it takes more than the idea. It takes more, especially in the circular economy side. It takes that whole enable environment stuff. I think that's what I was saying. But I don't think there's a particular time frame. Some people are able to go faster, some people, but I think it's when it gets to that level that ready to go.
Thank you, Prof.
Any other question? Yeah, hand over to Nitika.
Okay, thank you once again, Moira, for a really interesting talk. And thank you everyone for listening in for today's webinar. So the next month's webinar will be on the 3rd of September. So the invitation for registrations will be going out shortly. But thank you so much for joining and have a good rest of the day.
Okay.